Welcome to BKW Physics. My name is Mr. McConley, and I want to start by just a quick overview of different equations that we've been using up to this point. So, one of the first ones we started with was average velocity is distance over time. We then moved to an acceleration equation, which said the change in velocity over the change in time would give us acceleration. We rearranged that equation and actually got another equation that appears on the reference table, which is final velocity equals initial velocity plus acceleration times time. These are the same equation, but they actually do appear as two different equations on your reference table. And then the last one we did most recently was d equals vit plus 1/2 at squared. And these equations are allowing us to do a lot of different scenarios and situations. But up until this point, you notice we needed time for all these equations. Well, there's got to be an equation that allows us to solve similar problems without having time, and that's today's equation. So today's equation is vf squared equals vi squared plus 2ad. Notice no time appears in this particular equation. So this is your next reference table equation. And in order, the best way to work with these problems is to actually do a practice. And so I've asked one of my students to read a problem. And go ahead, and I'll write down the givens.
A race car can be slowed with a constant acceleration.
Okay, stop there. Constant acceleration, so I'm writing this down, of
negative 11 meters per second squared.
Got it. What else does it say?
A, if the car is going 55 meters per second.
Okay, so it's going 55 and it's going to slow down. So going means that they gave us an initial velocity, right? And you said 55 meters per second?
Mm-hmm.
Yeah.
How many meters will it take to stop?
To stop. To stop. What's the final velocity then?
0.
0. And they want to know a distance. So, I look at my givens, and like always, I try to pick the equation that's going to work. Since I don't have time, I'm going to go with my new equation, which might have seemed obvious because it is the new equation today. But when you're faced with a homework problem, and I'm not telling you which equation to use, you got to go through this mental process of picking it. So I need d. And in order to make that happen, the first thing I'm going to do is I need to get everything else to the other side. So I'm going to take the vi and subtract it to the other side. Still looking for d. So the next step I'm going to do is I'm going to divide by 2a. So I got vf squared minus vi squared divided by 2a. And now I'm left with my working equation. And life should go pretty smooth at this point because I just really need to plug in. But when I plug in, what do I always have to include in my plug-in? Not just the number, but the units. So let's do it that way. So 0 doesn't require the units because it's 0. But then minus 55 meters per second, that whole term is going to be squared over 2 times a negative 11 meters per second squared. So what's happening here is you notice you're going to be left with a negative on the top, but you're also going to have a negative on the bottom, so the two negatives will end up canceling each other out, giving you a positive distance, as you would expect. And when I do the handy-dandy calculator work, I end up getting 137.5 meters. Now, from what you know about significant digits, do you think that's the answer? A lot of no's from the room. So how many sigs do these have? So you're going to want to have 2, so that's going to make it like a 140 with no decimal point. And there's your answer. There's one example of using this equation. Let's do one more example. Moving to a problem that's labeled in the book as 24. Go ahead and read us that one, please, Cheyenne.
If a bullet leaves the muzzle of a rifle with a speed of 600 meters per second.
Leaves with a speed. So that means that's a final velocity, isn't it? 600. Yeah.
And the barrel of the rifle is 0.9 meters long.
Okay. 0.9 meters long. That's a distance.
What is the acceleration of the bullet while in the barrel?
Okay. What's the acceleration? But it seems like I'm missing something. Like, isn't there one more piece of information that was given but not directly given?
Yeah.
Of course. How fast did that bullet start when it was in the gun and you pulled the trigger? 0. Thank you. So now we have 4 variables. One that we don't know. Great, we can solve using our new equation, so let's do it. VF squared equals VI squared plus 2AD. Notice I'm being really particular about writing that equation every single time, even though I have it written 3 times on the board already, because I'm getting in the habit of writing it, because that's 1 point on the regions. So, here we go. We're trying to solve for A. It's going to be a very similar rearrange. I'm going to subtract the VI to the other side, then I'm going to divide by 2D this time, so I quickly rearrange for acceleration. Now let's plug in our numbers. We got 600 meters per second, that's all going to be squared. We got an initial velocity of 0 this time, and we got 2 times 0.9 meters. That's the sound of the calculator. You plug it in, and you end up getting a pretty darn big number of 2E5 meters per second squared. Okay? I wrote it as just 2 because of the 1 significant digit up there on the distance. So that's it for today. Physics.